Okay, here's the thing. I recently acquired an Elecraft KX2. I got this KX2 about 3 months ago. And the thing that's cool about the KX2 is if you order the KX2 as part of the Shack in the Box, you get this awesome case with it. And then I had an incentive to try to get everything into this little box. And the biggest obstacle to doing that was finding both a wire winder that was short enough. So I ended up designing this wire winder. It's dual-sided, which is really helpful when you're trying to get things into, when you're trying to fit a lot of wire, because this fits the full 67 feet of wire that makes up my end-fed half-wave. And it has a banana jack on the end of it. The banana jack is kind of important to me. I like the banana jack because, especially this particular specific kind of banana jack, because not only can you plug the banana plug into the end of it, but you can also, if the banana plug falls off in the field, which that has happened to me, that has absolutely happened to me in the past, you can just strip the wire with whatever you have available and then screw it down into the banana jack. So I wanted that. The other thing that I was trying to accomplish with this is I wanted it to be able to snap on and off. So I wanted the cover to be able to snap on and off. And here we have the core fits in there. So there's no hardware required. This just snaps on and off. And believe me, that took me a while to get that right. And then the other thing that I did that I've learned from making a few of these cases is you can see that this frame that this is all sitting in is open. And that makes things a lot easier to solder, because if you've ever tried to get a soldering iron inside of a closed frame, inside of a box, and not melted you struggle with melting the edges with the soldering iron. So I solved a couple of those problems. I wanted to design a case that would hold this specific core, and I'm going to leave a number for the core, or like a part number for this specific 43 mix core in the description to this video, so that you can order one yourself off of DigiKey. That's where I get them from, is DigiKey. They're a very inexpensive core. They're very small, and they're extremely efficient. Like, they're ridiculously efficient. Average is like over 90% efficient. They're actually slightly less efficient on the lower bands, like on 7 megahertz. They're a little less efficient on 40 meters than they are on the higher bands, but you get so much more efficiency on 20 meters and up that I think it's worth it. For QRP, this is only QRP. I mean, I wouldn't use more than 20 watts single sideband on this, and definitely not more than 5 watts digital. So I'm going to show you how I wind this transformer, and it is a bit of a tricky transformer to wind. It's not an easy one. Like, using a larger core is a lot easier to get that wound and get it to work. So this one is a little bit tricky, but I think it's worth the effort. I've made plenty of DX contacts with this core, and it works fantastic, including to New Zealand and Japan. I mean, Japan's not really a big deal from where I live. I live on the west coast of the United States in the Pacific Northwest, so Japan is actually a pretty common DX for us across the Pacific. I mean, it's like a lot of salt water between us and Japan, not difficult. But I've also gotten New Zealand and Australia with this setup. So that's pretty impressive. In my mind, that's pretty impressive. Wintertime is the best time to work on all your soda gear. So I chose a nice cozy winter night and sat next to the fire and wound my UnUn. So I'm going to kind of go over how I did this over here by the fire. Okay, here we are, nice and cozy by the gas fireplace. This is going to be a 21 turn 49-to-1 broadband transformer. The first step is to cut yourself 1 meter of 22 gauge magnet wire. I didn't plan it that way, but it turns out that 1 meter is the perfect length for getting all the necessary turns on this core. It's important to remember that every single time the wire passes through the center of the core, it counts as one winding. Leave yourself a tail of about 1 inch or 2 long to work with, and hold the wire tight while you wind it. The tighter the windings, the better it'll work. It's a little bit tricky to wind this without kinking the wire, so go slowly and be careful. Right after the third pass through the core, make a tap by twisting a loop of the wire about 1 inch long. I like this method better than the scratch and solder method that I've seen other people use, and I've tested the efficiency of both methods with all my cores, and there's no difference. So make life easy on yourself and create the coil tap this way. Once you've created that tap, pass the wire through the center of the core 18 more times. Be careful that you don't cross over any windings, and make this as neat and tidy as possible. Order a long spool of 22 gauge magnet wire, because you're going to need it if this is your first time winding a tiny core like this. You will mess this up. Do not be alarmed. You're not a klutz. This is hard. Once you're done, this will be your final product. Ham radio is a lot like fishing already. Now you're creating your own lures. So pat yourself on the back. Now let's solder this core into the winder enclosure and test it. Now that you're at the workbench, the first step is to remove the insulation from your connection points. There are many legitimate and effective ways to do this. Some folks turn the heat all the way up on their soldering iron and burn off the insulation. Some folks use a lighter. Steel wool also works. A razor blade works. Today I'm using sandpaper because I feel like it. Once you've futzed around and removed the insulation, you might find that it solders better if you dip the ends in some flux first. After pushing the connectors into the requisite holes in the case, which may require a little bit of reaming out depending on how accurate your 3D printer is, soldering the core in place is pretty straightforward. You solder the center of the BNC connector to the twisted wires, the end coming off the first 3 windings to the ground tab of the BNC. Don't solder the other end of the transformer to the banana plug yet. Leave it open for testing. Next, solder a 100 picofarad capacitor from the ground tab of the BNC to the center of the BNC. You might find it easier to solder the capacitor in place first. Your mileage may vary on this. If you'd like to test this before putting it in service, once everything is soldered in place, temporarily solder a 2.2K resistor to the end of the 18-turn secondary to the ground tab of the BNC plug. Connect your antenna analyzer or vector network analyzer to the BNC and set the range from 0 to 30 MHz. If you're reading SWR, you should see a curve that looks like this. That means your core is showing close to a 50 ohm load across the HF bands. Now, remove the 2.2K resistor, solder the 18-turn secondary to the banana plug, and put the cover on. You are now ready to wind your end-fed half-wave onto this winder and go call CQ. Enjoy your new antenna winder/matching unit. Now, get out there and go play with your radio.